Without further ado, let's start. We have as I said, big packed day. And the first speaker is Radovan Kopecek, co-founder and director of the research institute ISC Konstanz, a pioneer and a really pusher for many technology advancements. And I'm very much looking forward was what he thinks how the efficiency race for today's technologies looks like. Radovan, floor is yours.
Yes. Thank you, Michael. I'm extremely excited to be here. So thank you for the invitation, and also thanks you and TaiyangNews for being such a good partner. Also moderating many sessions that we had in the past, also regarding back contact technology, about gigawatt production in India. So let us continue to do this in future. Good. So my talk today will be, and as Michael already said, I'm one of the pushers of back contact technology. In the past, we were also pushing bifacial technology into the market. Now it's becoming, it became commodity, and I think the same thing will happen with back contact technology as well. And so today I will concentrate on back contact and also show you that it can be bifacial, and that with bifaciality it will come also into the utility scale market. So first of all, let me show you some slides about the market, what we believe will happen until end of the decade, but also until 2050. There are some nice publications about it. I'm sure you know it, but I will show you some more details. And very quickly, 3 slides about ISC Konstanz. Then I will dive directly into N-type technology, talk about mostly commercial efficiencies, because I think that in order to see what's really on the market, that it's more important that fighting for the highest efficiencies. Then dive into back contact technology and give you a short summary on the Bi-Fi workshop we organized together with ICO, and the back contact workshop that followed after that. So I like to start always with this graph, because this shows you how powerful PV is becoming. And in addition, I have to mention that this is only a start of a very successful era. So in 2024, we will have about 600 gigawatt installed. And so this yellow bar will be even bigger. And what this graph shows, so even Bloomberg now realized that photovoltaic and wind are getting the unbeatable technologies. But in 2027, and this is not only our forecast, but forecast of many others, we will enter a 1 terawatt era. That means that actually the yellow bar will shine all over the other bars. So PV will become technology number 1. And why is that? You all know about it, that the LCOE is getting down. So here you can see the LCOE comparison between conventional and renewable energy, and you see that solar in utility scale is going down to 1 cent per kilowatt hour. But what is really exceptional is what happened in the last years, that also storage became extremely cheap. That means in the next 5 years, we will see LCOEs here also in the range of 2 cents per kilowatt hour PV with storage. And this will make it extremely powerful. So this graph from the terawatt workshop is mentioned very often. But let me tell you some details on it. And so that means we will be still in a growth of installations in the next 10 years. reaching, let's say, stable supply, yearly supply of 3 terawatt per year. So we are still on this great exponential curve. Now, the thing is, what technology will dominate that? And of course, in the past, we had aluminum back surface field, and PERC in 2020 became the king of energy markets. Then TOPCon is now taking over, and there are now 2 consortia which are saying they believe more in heterojunction or in back contact. My understanding is that actually TOPCon and heterojunction will become back contact. Of course, the costs have to be reduced, but back contact will dominate then the market. And Longi is saying from 2027, 2028. And with this technology, in my understanding, we will reach actually these 3 terawatt a yearly installation. And why? Because we are still on this very fast learning curve. And this is my last slide. I want to show you a very nice publication from NICE, who is showing that actually in 2023 or 24, there are similar numbers. The world's PV market with storage is dominated by 2 technologies, wind and solar. The thing is now that in 2027, if we still are on this fast learning curve, and we are, because at the moment, the average module efficiency is 22.5, maybe going to 23% with good PERC, with good TOPCon. Of course, we have also 24% from ICO, but ICO is not the average at the moment. So we will still have 7 years from now if we continue this learning curve, 0.4% absolute inefficiency to reach about 25.5%, which is still possible. And also the bifaciality will kick in also in the back contact. That means that actually from 2027, there will be no cheaper energy source with storage globally than PV. And of course, in 2030, it will be even lower cost. That means PV will be the source to choose for the future. Of course, it has to be combined with wind, with storage, hydro, and so on. But this is just to show you that PV at the end until 2050, and I can come back to this graph, will have a total capacity of 80 terawatt, which means 80% of the total energy market will be produced, the electricity from PV. Okay, and which technologies will that be? We believed still TOPCon and back contact, 50-50 in 2027, and then in 2030 it will be back contact. So this is just a teaser for what is coming now. So very shortly, ISC Konstanz, for 19 years, we are now involved in the development of N-type. I actually started already 20 years ago at the University of Konstanz. We had also some first development of this structure. And we were saying already from that time that the market will be N-type in future because of many advantages of N-type. This is our group at ISC Konstanz. We are 65 people and growing. The highest efficiency in the market, which we transferred, was the SPIC IBC in 2019. I will show you some picture of that as well. And transfer technology so far was about 4 gigawatt in total. But this has been about 10 projects in Europe, India, and China mostly. And this is the menu that we are offering to the investor and to the companies. Of course, we have TOPCon 1.0, but working also on so-called double poly. And our biggest advantage of the concepts is that we can already include screen printed copper, which is done in collaboration with Coprint. And then we have on the other side also back contact technology, Zebra 1.0. This is still a solar cell without any passivating contacts, and are at the moment developing Zebra 2.0, and will transfer this process to Futura-san next year. And of course, all of these technologies have also copper screen printed. And then, of course, all our concepts are tandem ready. So now coming to N-type technology, what is happening in the market, and Michael already showed the ranking, and I like this ranking very much. Thank you for publishing this every month. And since a couple of months, all these three companies, which will present after my opening talk, ICO, Maxion, Longi, are leading the ranking. And so the IBC solar cells at the moment have module efficiencies, which is really amazing, 23.2, and even exceeding already 24%. That means for 24% module efficiency, you have to have at least a solar cell which is 26 plus. And heterojunction at the moment are between 22.5, having slightly higher efficiencies than 23%. Is one company, Huasan, and Topcon is between 22.5 and 23%. So there is advantage, efficiency advantage, and that back contact will really become mainstream. Of course, the costs have to be reduced, or for example, the copper metallization has to be implemented. But I mean, there is no doubt at the moment that back contact technologies are leading the high efficiency table. So this is from our NPV book, some information about all the concepts that are existing on the PV market. We have discussed already many of them, so heterojunction, Topcon, and in the book, unfortunately, we underestimated in 2023 the power of Topcon. But now with LiCo and Topcon together, we can reach already voltages of 735 plus millivolt. That means many Topcon producers are arguing maybe that the back contact junction will become obsolete because implementing P plus polysilicon will not lead to a big advantage, which is maybe true, because 742 at the moment reached by ICO is not a big step. However, it is a step, so you can see it on in the efficiency table, also because you have no front side shading, but there are many more advantages to IBC, which I will show you also later on. So we are, let's say, quite sure that the next step is the back contact technology. So as I told you now, as I told you already before, there have been a couple of eras, P-type low cost, P-type bifacial, which we are now leaving and entering, or we are in the middle of the N-type bifacial era. And now the decision will be going to double poly or Topcon back contact. And of course, for example, the fingers on the front side are printed also shallower, and you have the zero bus bar technology, which, let's say, if you look at the modules, that the front contacts are hardly visible. But to our understanding at ISC Konstanz, because we are working for 15 years now on the back contact technology, it is simpler actually than the double poly, because here you have to really be very accurate and hit the lines, and it's also not very easy to make a selective polysilicon. So this is a simpler structure if you have the technology ready, which is, for example, fast lasers and others. When this tandem technology will come, we are not very sure, because there are still many challenges out there. So what will happen, and what happened in the past with N-type technology, that there were innovators in the beginning, and also, for example, Saniva, Silevo, Mission Solar, PVJ. So there were many N-type believers that adopted the technology. Then there were first early adopters. Then the change is happening always when the tier one manufacturers take over. And we believe that a similar thing will happen now with back contact. So in 2023, we had a switch to N-type. Post 2025, I think in 2027, 28, we will have a switch to back contact. And here you can see how we believe it will happen. Because if you have a switch from one solar cell type to another solar cell type, there have been many things to be developed. And so, for example, what happened in the aluminum back surface field case, the most important thing was that low-cost Czochralski silicon was brought into the market, and that was done by Longi, and that was the big breakthrough for PERC, but also by faciality, for example. Then how PERC became TOPCon. The most important thing was LiCo, as I told you. So now the TOPCon is extremely powerful because of the after processing of lasering the fingers. And what will happen now within the next years until 2027? So we have been already working on back contact interconnection for a long time. So this is finished. But for example, copper screen printing will be extremely important, and also still laser structuring. So lasers are getting more and more powerful, and that's why it will be possible in future to make back contact also lower cost. Going from back contact or double contact to perovskite, this will take still quite a long time because there are many problems which are not yet solved to our understanding. So in 2027 plus, our vision is that we will have modules out there with 25% efficiency, which is back contact, temperature coefficient well below 0.3% per Kelvin. Bifacial factor will be between 70 to 95, depending on which technology you choose. And as I told you before, LCOE will go below 1 cent per kilowatt hour, and with storage about 2 cents, or in future even below 1 cent maybe. So very quickly now, how was IBC possible to that it gets now the next level? I think that with ISC Konstanz and SPIC we pioneered IBC technology, and what was important at that time, the laser structuring. We cooperated at SPIC with DR laser, and now DR laser is actually the technology in laser that can bring back contact technology to low cost. Then back contact interconnection, as I told you, normally SunPower was connecting at the edges, but we have this classical stringing which we developed with SPIC, and this classical stringing is also used in production also at ICO. But the important thing was that the half cell technology was brought into the market, because the bowing of full cell would be too much. So what is happening now in the PV market, and Michael already said that there are a couple of IBC technologies. So for example, P-type technology, Zebra, so it's this IBC without any passivating contacts. But now, and this is good news, that everybody is now focusing on one IBC technology, which is TOPCon back contact or heterojunction back contact. It has the same structure, so both passivating contacts. And this is, let's say, a start when a technology can become big, that everybody is working on a very similar technology. So ICO and Maxion, you will hear the presentations from them. Now also Longi. We have contract with Futura-san, then SPIC, and maybe there will be also a project in Europe soon with Carbon. So as I told you, we have a contract with Futurasan, and we are very proud that in the next year we will together bring poly zebra into the Chinese market as well. Now I have, I think, 2 more minutes to summarize the workshops we had in China first. So thank you very much, ICO, that you made it possible to bring Bi-Fi PV workshop to China. That was always my dream, to have this workshop also taking place in China. It was a 2 days workshop. We had 400 visitors on site. ICO said there were 170,000 online, looking not on the whole event, but at some parts. And there have been 7 sessions, including panel discussion. The questions were what we will discuss also here. When will back contact become a big thing? What are the chances? What are the challenges? Then tandem, how and when, advanced module tech, and things like that. And the summary of the outcome, we had also a big plenary discussion, which was led by Min Ge from TaiyangNews. Very good plenary discussion. Thank you very much for that. The outcome is that the material quality is becoming semiconductor grade. Laser technology is very important. Zero busbar technology also in back contact can be used. Bifacial back contact is already entering the utility scale now. And the bifacial factors are actually not much smaller than for TOPCon at the moment. For ICO, it's 73%, and the goal is to reach close to 80%. And there was a technical discussion. There was a press conference also where Longi was saying that actually back contact technology will be the next big thing from 2027. That also happened as a parallel event on the Bi-Fi PV. Now, my last slides. Then we had a 2nd-day workshop at University of Delft. Of course, not as big as in China. We had about 50 visitors, and also a panel discussion. Here you can see the David, which is working for SunPower. So he is more or less the dinosaur in back contact technology. And he was saying actually that for him, the most advantage of back contact technology is the low breakdown voltage, which will be key, because of course still you have this bypass diodes, but the low breakdown voltage is protecting the module. And then there were more or less same outcome. Lasers are extremely important. Bifaciality will come. And the goal is to get to high bifaciality and more than 25%. So my summary and 3 takeaways: that bifacial NPV, of course, we know it's the new Emperor. TOPCon and heterojunction is used for utility scale. Quality is good when you have the process under control, so you can have N-type modules with a very low degradation. Of course, there can be also modules with high degradation if you do not know what you are doing. Then back contact at the moment is already entering utility scale. So I talked to ICO, and they have already big projects, even if the bifacial factor is at 73%, or even without any bifacial module. And bifacial back contact will dominate from 2027, 2028. And the biggest advantages of back contact tech is the high efficiency, but also the low breakdown voltage. And sustainable development will be key, changing from silver to copper. And with this, I would like to also invite you for the next Bi-Fi workshop in Chile, and silicon PV and PV, where we will also discuss tandem technologies. Thank you very much.
Thanks, Rado. Great overview, great insights. We will then discuss more about that during the panel at the end. So we have really this dense schedule today. So let's continue.
Okay.